In this video, we will investigate several more examples of finding the equation of a tangent line. So in the first problem, we will find the equation of the tangent line to the curve y equals square root x at the point 1, 1. So keeping in mind what we need to find the equation of the tangent line, it's a line, so we need a slope and a point. The point is given as 1, 1, and what we need to do is find the formula for the slope of the tangent line. And recall that that formula is given since it's at x equals 1, the limit as h approaches 0 of the quantity f of 1 plus h minus f of 1 over h, where for this problem f of x is the square root of x. So doing our function valuation, if f of x is the square root of x, so whatever we plug into the function goes underneath the square root, f of 1 plus h will be the square root of 1 plus h minus f of 1, which is 1, all divided by h. And this becomes a familiar type of limit that we encountered in Chapter 1, so ideally we would just be able to plug in h equals 0. But of course that doesn't work because the expression is then undefined. But because of that square root in the top, that's an indicator that maybe what we should do is multiply by 1 in the fancy way where we take the conjugate over the conjugate. Now when we do so, this simplifies the numerator very nicely. It's just the difference of squares formula. We get the first term squared, which is 1 plus h, minus the second term squared, which is 1. Then in the bottom we have the h, which is there, and the square root of 1 plus h plus 1, which we've multiplied by. But notice 1 minus 1, h over h. And what that does is it leaves us with the limit as h approaches 0 of 1 over the square root of 1 plus h plus 1. And at this point, we do not have a rational expression or a polynomial, so we cannot just use the substitution property. The problem is the square root there in the bottom. But what we can note is we've evaluated several examples of this form, and we've seen how we can apply our limit laws. We're going to take the limit of the top, divide it by the limit of the bottom. And when we take the limit of the bottom, we're going to break it up in terms of the limit of the first term plus the limit of the second term. And in that first term, we're going to take the limit and push it inside the square root. So that would be the limit as h approaches 0 of 1 plus h. And now we can simply plug in h equals 0 because 1 plus h here is a polynomial. So using the substitution property, the limit of the first term in the bottom will be the square root of 1. And the other two remaining limits are simply constants. And the limit of a constant is that constant. So the value of this limit ends up being 1/2. And 1/2 in this problem is the slope of the tangent line. So putting this together, the equation of the tangent line in point slope form will be y minus 1 is equal to 1/2 x minus 1. And this simplifies into the slope-intercept form, y equals 1/2 x, and then we'll have minus 1/2 on the right, plus 1, which gives us a plus 1/2. Okay, so one more example finding the equation of a tangent line. Here it will be to the curve y equals minus x squared plus 2x plus 2 at the point on the curve minus 1 minus 1. Now once again, taking that big picture perspective, in order to find the equation of a tangent line we need the slope, which we will calculate, and we need a point. And minus 1 minus 1 is a point given. So the point slope form of the line will be y minus a minus 1 equals the slope, which we are going to find, times x minus a minus 1. So in order to find that slope, we're going to use this familiar form. It's at the point minus 1. So it's the limit as h approaches 0 of f of minus 1 plus h minus f of minus 1, all divided by h. And in this problem, f of x is minus x squared plus 2x plus 2. So we have to be very careful when we perform the function evaluation. Anything we plug in for x needs to be substituted in for both of the x's we see in the equation of our function f. So f of minus 1 plus h. This is going to be minus the quantity minus 1 plus h squared plus 2 times minus 1 plus h plus 2. And that entire quantity there, these three terms, is f of minus 1 plus h. And then we are subtracting away f of minus 1, which is the number minus 1, and we are dividing everything by the h, which is present. So once again, we're in the position where we would love to plug in h equals 0, but unfortunately it's undefined. So what we need to do is algebraically expand. So let's just go through piece by piece in the top. So we have minus the quantity minus 1 plus h squared. So we'll keep the minus out front, and if you square minus 1 plus h, we will end up with 1 minus 2h plus h squared. Then in the next term, we can distribute the 2. So minus 2 plus 2h, then plus the 2, and then minus a minus 1 becomes a plus 1. And we immediately see that we are going to get some nice cancellations occurring here. We will have a plus 2 and a minus 2. The minus needs to distribute through this first term, and when it does, you will have a minus 1 and a positive 1. And everything else in the top will remain. You have an h squared with a minus sign in front of it, a plus 2h, a plus 2h, all divided by h. But luckily, we're in this situation once again where each term in the top has an h in it. So pull that h out, and you're going to be left with a minus h plus 4 all over h. Cancel the h's. What we are left with is a polynomial, so we can use the substitution property. Just plug in h equals 0. And the value of our limit is going to be 4. The number 4 corresponds to the slope of the tangent line. So if we simplify this down to slope-intercept form, we'll have a 4x plus 4 minus 1. So 4x plus 3.